Okay, so we've seen this formula. S is equal to r theta. When we differentiate, we're gonna get ds over dt is equal to r d theta over dt, and this one is actually converted to become v is equal to r omega, right? Because ds over dt is your velocity, d theta over dt is your angular velocity. So what happens if you differentiate this again? You're gonna get d2s over dt squared, right? Or it's also equivalent to acceleration. So this one is going to be r d2 theta over dt squared. So this one is actually equivalent to a acceleration r. This one becomes alpha. So this is actually a tangential. Alpha is your angular acceleration lah. So yeah, these are the important things. From here you get these things lah. A is equal to r alpha. So this is the next part of the equation that we derived based on this one. S is equal to r theta. Where does this come from? It comes from your circumference. 360 degrees is equivalent to 2 pi, and your circumference is your S. Okay, so now you're good to go to do some exercises. So let's look at the first one. This is a gear. This gear, when the gear rotates 20 revolution, it achieves an angular velocity of omega is equal to 30 radian per second starting from rest. Determine the constant angular acceleration. So this one is pretty straightforward. 20 revolution, this is your theta. So the theta becomes 20 rev. So 20 times 2 pi. So you get 40 pi radian. This is the theta. If you are not familiar with theta, it's equivalent to S lah in linear term. Omega, okay, omega is straightforward, constant angular acceleration. This one is your alpha. So if you don't remember the angular formula, remember the linear formula. V is equal to V naught plus AT. Omega is equal to omega naught plus alpha t. So at least remember the linear one. You can derive angular easily. So omega. So this is theta, right? I don't have theta information here. No theta information. Maybe the next formula code. So S is equal to S naught plus V naught t plus half A t squared. So this one becomes theta is equal to theta naught plus omega naught t plus half alpha t squared. Maybe it's this one, I'm not sure. Do we have enough information? Starting from rest, I think we don't have time, right? We don't have time. So maybe we don't have enough information. Maybe we need more information. Okay, let's look at the third formula. V squared is equal to V naught squared plus 2A S minus S naught. So now this one becomes omega squared equals omega naught squared plus 2 alpha theta minus theta naught. This is the third formula lah. Maybe it's this one. Third time is the lucky time. Third formula. Omega squared. Apa dia nak ni? Determine angular acceleration. Okay. So this one is final velocity lah. 30 radian per second. Original velocity 0. 2 alpha tak tahu. Theta minus theta naught. This one lah. 40 pi minus 0. Yeah, from this you can get alpha. So alpha becomes 30 squared divided by, ini apa 80 pi. Correct ah? 30 squared divided by 80 pi. Should be. Let's try. 30 squared divided by 80 divided by pi. 3.58. 3.58 radian per second squared. Betul. So the time required. So when you are looking at time required, you cannot use formula number 3. There is no time here. Probably you can use formula number 2 or formula number 1. So we're not sure yet, right? So I hate to use formula number 2 because it's so long. Maybe we can use formula number 1. Yeah, we can use formula number 1. Omega we know already. Omega is equal to omega naught plus alpha t. Omega is the final velocity, right? Omega minus omega naught divided by alpha. You're gonna get time. So 30 minus 0 divided by 3.58. Dapatlah time. 30 divided by, yup, you got it. 8.38 seconds. This is the time. Okay, so we are done. Next. Yeah. This is something else lah. Before we do this, I guess I should teach you something else. I guess I should teach you something else. Okay. I gotta add one more here. New slide blank. Okay, so let's say you have, let's look at a bicycle. Bicycle, kita ada front. This is a front sprocket. This is the, what is this? The rear small sprocket. So let's say this one, the radius is, look at your bicycle. Radius R. Radius berapa? 10 cm too big. Never mind, 12 cm. This one, the radius is slightly smaller, probably R 3 cm. Okay, so this is looking at your bicycle. So you've got something called the chain. So this chain surrounds the two things. So what are we calculating? Okay, never mind. Let's do this first. So we already established and we have confirmed the formula of this one. S is equal to R theta, V is equal to R omega, and A is equal to R alpha. So this one we have derived and we can use without any conviction. We know how to do it. So when you have something like a belt or a chain, so this is a chain. Uh, the chain is a continuous object. So this chain is continuous all around. So when the chain moves, it will share. So when the chain moves, it will share common tangential velocity. So this will share common tangential velocity. What do I mean by that? It means that if you are sitting here and this thing is rotating, so you move forward, right? So the velocity that this guy called A moving, VA, is actually equivalent to this guy. This guy is at the bottom. So this guy travels like that. This guy's name is VB. So VA and VB is actually similar. Why are they similar? Because they are on the same cable, same belt, same chain. So they share common tangential velocity. So it makes sense. So wherever you are on this belt chain driven thing, your tangential velocity, remember, tangential is tangent lah. Let's say this guy is called VC. Sama juga, same. If you are here, you have a tangential velocity in this direction. Sama juga, same. VA sama dengan VB sama dengan VC sama dengan VD. You share all common velocity. Why? Same cable, chain, belt. Same thing. If you're on a gear, similar things happen. You also share common tangential velocity wherever you are. Why is that so? If this gear rotates like this gear will rotate like this. So over here, they will share common velocity because the gear are synchronous. If this one rotates like this one has to rotate like that. Over here, the gigi of the gear, they are in mesh with each other. So this is the teeth of the gears. You've got gear teeth of a different color. So yeah, same. The teeth cannot be running at the different speed, otherwise the gear will become broken already. The gear is running at synchronicity, synchronized. So this one rotates like that, this one rotates like this one will rotate the other way around. So they will share common velocity. Let's say this thing is VA, this thing is VB, this thing is VC. VA equals VB equals VC. Same. Yang dia tak sama adalah omega. Omega A, omega B, omega C. Omega A is not equal to omega B, is not equal to omega C. This one is of course one is moving faster, the other one is moving slower. The biggest wheel, slowest. Medium wheel, medium lah. The smallest wheel, fastest. So smallest wheel is the fastest. So how about over here? Same case. If this thing is what do I call this one? 1. I call this one 2. Omega 1 is not equivalent to omega 2, but V1 is equivalent to V2. So what I mean by V1 is the tangential. This is tangential, okay? Tangential part. Should I remove this, Are you guys okay? Tangential velocity they share lah. Tangential. So what do I do now? Should I remove a few things? I think you guys can take note, right? So let's remove a few things. We haven't done the deeds, Okay, remove. Because we're trying to solve this bicycle thingy. This is a bicycle. What else should I draw here? Okay. So V1 and V2. So you know at location V1 is equal to omega 1 R1. Okay. How about location V2? V2, okay, let's do something like this lah. V2 you know already is equal to omega 2 R2. So one thing we know for sure is tangential velocity. Maybe I draw here V1 and then I draw here V2. We know for a fact V1 is equal to V2 because they are on a chain, on a cable. So this equation can be simplified as omega 1 R1 equals omega 2 R2. So this is something that you can use. So same goes. Currently we are analyzing V1, right? So A1 also equals to A2. So same rule follows. R1 alpha 1 is equal to R2 alpha 2. This is for acceleration tangential. Okay. We haven't give any proper values here. So you got here 12 centimeter. Okay, let's rub off few things. Okay, so let's look at some values. Let's say this thing is rotating at berapa? You cycle your bicycle, let's say 60 RPM. Correct? So if the front part you are cycling at 60 RPM, what is the rear part speed? Omega belakang berapa? Omega 2 berapa? So this one is very easy. You just have to use equation this one lah. Use this equation. Omega 1 R1 omega 2 R2. Omega 1 is 60 RPM times radius 12 centimeter. Omega 2 don't know. Radius belakang is 3 centimeter. So I don't have to change my units. The units will cancel out. So I'm saved by that thing lah. So omega 2 is equivalent to 60 by 12 divided by 3. So rear wheel is rotating at 240 RPM. So get the whole of that. So this thing is rotating at 60 RPM. This thing is rotating 4 times faster. Okay, so look at the radius. Radius here is 12 centimeter. Radius at the back is 4 times smaller. So the rear wheel will rotate 4 times faster. So what now? You know, rear wheel is rotating at 240 RPM. So now let's give a few more things. Let's put the rear wheel. The rear wheel color apa? Why do I have so small? Orange green color lah. Let's do a green color wheel. So at the back, let's say this thing is attached to a bigger wheel. This is the wheel which is rotating on the ground lah. This is the ground. Let's say this is the ground. So what is this tire radius? Let's see, the radius is 40 45 45 centimeter, makes sense 55 centimeter. So if the rear wheel is radius 55 centimeter, so you know for a fact already. What is the fact? The front rotates at 60. The rear rotates at omega 2 240 RPM. So if the rear sprocket, this is a sprocket if the rear sprocket is rotating at 240 RPM, the rear wheel also attached to the same sprocket. Omega 3 is also rotating at same 240 RPM. There you go. So you know lah. So if the rear wheel is rotating at 240 RPM, so berapa laju basikal? What is the speed of the bicycle? What is the speed of the whole bicycle moving forward? Ni berapa? The speed. So in order to solve this, you are using the relationship of linear convert to angular, angular to linear. So same thing lah, you have to use this formula. Yeah, use this formula. Linear equals omega r. So you gotta change first lah. RPM change to radian per second. You still remember what is the formula? The formula would be omega equals 2 pi n over 60. So this formula never forget in your life lah. Omega is 2 pi n over 60, right? So this formula becomes, how do I make this better? I don't have space. V is equal to omega r. So V is equal to 2 pi n over 60 times radius. Now you can do it. Let me rub a few things off, and we can settle this thing. So velocity 2 pi, RPM 240 over 60. Radius of the bike is 0.55 meter. So what do you get? 2 pi times 240 bahagi 60 times 0.55, 13.82. So it's traveling at 13.82 meter per second. How many kilometer per hour? Multiply by 3.6. So this guy is cycling at 49.7 kilometer per hour. See? So this is how you can calculate linear speed lah. This is how you calculate linear speed. So keep again, I have to insert again. So when you graduate, you're gonna buy a car. This is your car. Looks so bad lah. Let's say this is your car. So this is the car you buy when you graduate. Okay, let's say you bought a car. Your car has wheels. So your wheel is like this. So typically, people are gonna buy how much? R14-inch wheel, R15, or jump to R17-inch. So there's a lot of wheel sizes lah. So the speedometer of your car calculates the speed going forward by using data from your RPM of the wheel. Wheel RPM. So let's say if your car is current wheel size is 14 inch. Yeah. Let's say if your car is calibrated for 14 inch. So when you drive 110 kilometer per hour, it is 110 kilometer per hour because your car tire wheel radius is 14 inch, so 110. Because it takes the RPM of the wheel. So let's say if you upgrade, let's say you go crazy, R18. You go even crazier, R19, got Now you change. First salary by wheel, 19-inch wheel. So, will your tire RPM become slower or faster? Let's say old one like this. Since you have a bigger wheel, does it rotate faster or slower? What happens now? What happens now? What are you going to do? What are you going to do? Okay, got it. So if you change to a bigger wheel, your wheel will, the RPM is slower at 110 kilometer per hour. Yeah. RPM is slower lah because you have a bigger wheel. You need to rotate slower. So if your speedometer is showing 110 kilometer per hour, it's not actually 110 kilometer per hour. It's much higher. It's higher by how much? You have to calculate lah. Maybe it's 130 kilometer kot. Maybe you have to calculate. Use back this one. V is equal to omega R. Okay. So if you do something like this, you have to recalibrate back in your ECU. ECU ka? Engine control unit. Go to the dashboard unit. You have this ODB connector. ODB stands for what? On board diagnostic code. Diagnostic OBD or ODB or something like that. Yeah, it's not ODB OBD. I think OBD2 now. OBD punya on board diagnostic. So that's the story lah. punya banyak story ya. Now you can solve this. What time is it? Still have more time. Let's solve this simple one. What is the angular acceleration of gear B? Where is our gear B? This one, If gear A has an angular acceleration of alpha A 125. Okay, this is so easy. This one rotates at 125. Ini rotate macam tu. This one will rotate this way lah. If this rotate this way, this one will rotate this way. So similar size, similar RPM. So this one also same. 125 radian per second squared. What is not omega? You're looking at alpha B. So use this formula lah. Alpha A 125 times 50. This one alpha B don't know times 75. So alpha B is equivalent to, ada jawapan tak? Tak ada jawapan lah. Punch in your calculator lah. 125 times 50 divide by 75. 83.3 radian per second squared. Acceleration here is slower. So now you can look at teeth. You can do the same deduction with teeth. So the relationship is alpha 1 R1 equals alpha 2 R2. And if you're looking at velocity, omega 1 R1 equals omega 2 R2. So if you are looking at gears, the teeth size are all the same. You cannot have one gear bigger teeth, the other gear smaller teeth. No. The teeth will all be the same size. So the bigger your radius, the higher your teeth count. So normally if you don't have tools to measure radius, right? Radius is crazy to measure. You always have caliper, right? Caliper you can only measure diameter. So when you work, people will give you diameter. Radius is a byproduct of diameter because radius is impossible to measure. You can never get the center part. So you can use this one as this one lah. Omega 1 teeth 1 equals omega 2 teeth 2. So the bigger your radius, the much more teeth you have. You can calculate teeth lah. I think I have somewhere here in terms of teeth. I have some formula here. Where are we? So much. This one. This is the formula for teeth. Gigi. Gigi orang. Okay. Omega 1 teeth 1, omega 2 teeth 2. You can even use radius. Similar thing. Easier to calculate teeth. Kira teeth, there no need to measure diameter. In the industry, that's what you do. This one is done. Can we do this one next? Yeah, we got time. Really, maybe we don't have time. I'll continue.